Hey everybody, this is Larry. This is day 28 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. Happy Thanksgiving by the time you watch this. Yeah, hope everything's well. I don't know. I have not much to add today, so let's just get started. Let's just go. Alright. Today we have 2290, minimum obstacle removal to each corner. You're given a 0 next to the integer array grid of size, I always say R times C. Each shell has one of the two values, 0 and 1. 1 is an obstacle. You can move up, down, left, right. Return the minimum number of obstacles to move, so you can move from upper left to bottom right. So, okay. So, I mean, there are kind of a couple of ways you can think about this. This is the longest path. Oh, sorry. This is the shortest path from the upper left to the lower right, right, up, down, left, right. An obstacle gives you a cost of 1. Anything else is just a cost of 0 because it doesn't, minimize the number of obstacles, and everything is free in this, or like everything is available, not free as in, everything is available, to go. You just have to kind of do that. And one observation to make, of course, is that the number of obstacles, that the max number of obstacles you can make is 2 times n, right? Or R plus C, maybe more precisely, because if you just, if you take the longest path and you hit all obstacles the entire time, you're going to see R plus C, right? Minus 1 if you want to be more precise, maybe, depending on how it is. I think this is, yeah. One thing, and yeah, you have to make sure that, I think one thing that, maybe not this one, but there are problems where they will have like an obstacle at the upper left corner to kind of fool you for like the cost of 1 or something. So it's a little bit weird, but anyway. Yeah, I mean, I think that's mostly it. But once you realize that all the costs are 0 and 1, and then you get to process them in order. So, I mean, before you can probably use a heap, but if you kind of follow along what I said, you can actually use something called a 0-1 breadth first search, and that is what I'm going to do. Basically, the idea behind 0-1 breadth first search is that because I think it's easier with visualization, and if I could type this thing correctly, it's a little bit easier with visualization. And the idea there is, let me just draw it out really quickly, honestly. Right, and the idea here with a 0-1 BFS is, I talk about invariants a lot, so let's talk about more about invariants, right? And invariants, things that don't. This is a terrible straight line. I hit my elbow on something as I was drawing it. Maybe I just don't know how to draw straight lines. Let me. That was straighter, but then I went off the page. Okay, so let's say we have a straight line, and this is the front of the queue. This is the back of the queue, right? And this is a queue, right? And the idea, the invariant that allows you to do, and I honestly, like, people try to memorize these things, and I don't. I just remember the invariant. I don't know, maybe you could call it memorization, but everything else flows from the invariant, right? And the reason why 0-1 works is that basically, that everything up in the front is going to be the current, say, D for distance. This is going to be plus 0. There's some cutoff, and then everything is going to be plus 1, right? So as a result, the invariant is that, well, if you encounter a new cell or a new distance or a new node or whatever, then now it's only in 1-2 buckets, right? And because everything in the 0 plus 0 bucket is the same distance, you can really process them at any time for greedy reasons, and everything in the plus 1 reason is the same thing, right? So because you can process them at any time and you can insert them at any time, that means that, maybe you can insert it here, maybe you can insert it here, but it doesn't really matter where you insert it. Really, you can insert in the middle. And conventionally, the way that I think about it, though I actually never thought about it this way now that I think about it, as I said, then the convention by 0-1 BFS is that you insert in the beginning and the end, because we have, for a regular queue, we have a easy you know, access to the beginning and the end. But the way that, I guess, like another way that I think about it, just from the invariants, and this is just off my head talking about it right now, is that you can actually just have two queues, right? If you have two queues, then maybe that's a little bit clearer. I don't know, or it's just a little bit different, where you have a zero queue and a +1 queue, and then once this finishes, you can keep adding to it. Then now your +1 queue moves to the +0 queue, and then you just have a new +1 queue, right? So there are different ways you can think about it, and you can add to the back if you don't like adding to the front. But like I said, the most important part are the invariants, and having the invariants, you know, will allow you to kind of make these observations for different, you know, for solutions that are slightly different, say, right? And yeah, so let's go. Yeah, so we say, you know, we have a queue. Yeah, and you know, we have to set it up first, but you know, this is just general queue setup things. Yeah, and then we have a queue. We want to append. So this is where I don't know if it's this one, but there are a couple of Leetcode problems. They, like I said, they put an obstacle at the starting point to kind of as a trick case. So we have to be careful, because it's very easy to write like this, where the dimensions are going to be the distance, x, y, right? But yeah. But as a result, the distance for the first one may not be d, right? Because, well, it might have an obstacle. So basically, maybe I just write something like, I don't know, over 0, 0, if grid of 0, 0 is equal to 1, then, I don't know, something like that. I don't know. Maybe I'm being too cautious. I don't even know if this is this problem, but I just know that you know what they say, right? Fool me once, shame on you. Fool me twice, maybe shame on me. But, and I feel like, what do we call it? Leetcode has shamed me a lot, or fooled me many times. I'm very shamed. But, yeah. Alright, so we have this thing for directions. The way that I always say it is that these are dx, dy, so just up, down, left, right in some order, not that order, right? So then you could do something like this. There are other things that I have to set up actually, but I just want to like explain this part by writing it, is what I mean, right? But yeah, we also want to set up the distance. We can set distance as a grid, so maybe none times c for right? And then here we can yeah, well, we can put this here, I suppose, and then distances of 0, 0 is equal to O or something. And then yeah, and then now we queued it, we check it, and then now we go, okay, well, if the distances of nx and y is none, that means we haven't visited yet, right? Then we do want to visit it. And what is the distance? Well, so if grid of nx and y is equal to 1, then it's going to be d plus 1. So yeah, it's going to be then we want to insert it in the back. So yeah, distances of nx and y is equal to distances, or just d plus 1, and we want to insert it in the back, right? Else we want to insert it in the front. And that's pretty much it, right? And then we just return distances of what's it, r minus 1, c minus 1, and they're always, and I usually sometimes like check like, okay, what is the impossible case? Do we have to return anything? In this case, there's no impossible case. Like I said, the worst case is just gonna be r plus c minus 1 or something. Of course, if it doesn't always work, then you know, because it returns none. So I mean, this is just very awkward in general. I missed something that I usually write, which is that yeah, that we have to stay in bounds. But usually that would give me an error. Except for in Python, it's always a little bit weird sometimes on these out of bounds things, because it could give you a -1, and -1 isn't actually out of bounds in Python. So, but what? It's a little bit awkward that everything is 0. Did I just not reach it, or? Huh. Dun dun dun. damn it, I must have a silly typo somewhere. I don't know. Well, it doesn't even go for this loop. Oh, why did I less than 0? I mean, I don't know. Some days you're just being a little bit silly, but yeah. Well, I mean, either way, this is way wrong, obviously. Oh yeah, I think but I'm just reading this, and yeah, one thing about removing is that if you, I said going through an obstacle, but when I say that, I meant like you remove it is effectively, you know, going through it. But why is that? That's not even close, honestly. All right, so 0, 1. 0 and then 2. Why is this 2? Oh no, 2 is here, and then this is 1 on the. Sorry, I'm looking at like the third row, column 1. What? Huh? I think so off. I was gonna. I'm ready to like take go to sleep, but you know. Sometimes Leetcode has not even Leetcode this time, just my silly plans. So okay, 1 1 2 2. Did I have a typo? No. Do I have a typo here? No. Oh, that's no. 0 0. Yep. Oh no, it then goes to 1 0 2 0 2 1, but that should not. The D is wrong. Did I append the wrong thing? D. Am I confusing it? That may be removed. No, that's right. Grid NX and Y. That's right. What am I doing wrong? I'm doing something wrong, clearly. But the idea should be right. Oh man, I feel like I don't know how to program anymore. Like I feel like I've been solving the actual problem okay, but 1 0 2 0 2 1. But even 1 0 should not be distance of 1, right? So this is just wrong. Oh! I'm just being dumb. Why is this +1 here? I mean, so it probably messes this thing up because it propagates in a weird way. That's why I was inconsistent. Okay, because it didn't even make sense from like it wasn't just that it was wrong, but with some experience, you notice that it was like inconsistently wrong in a weird way. That wasn't. But yeah, I don't know. Maybe I was just copying, because I think that's just like the very common way of doing it. That I don't know. But yeah, I guess I didn't make a mistake last time. I wonder if I checked the corner case. I guess no. Yeah, last time I didn't do it, and I did it with a heap as I said that you could. But you can also do 0 1, and the performance here is better, right? Because every cell gets looked at least, or at most once, at least once, and at most once. So it's going to be perfectly linear. Of times C is linear because it's the size of the input and the output. So linear time, linear space, and yeah, that's all I have for this one. This is the obstacle remover. I don't know why they, what do they try to suggest about my Thanksgiving? Something about obstacles? But anyway, that is all I have for today. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.